Hi everyone. Let us solve simple circuit using Ohm's law.
Example 1. Let's talk about it with another combinational circuit. Here, two resistors A and B are connected in series with a voltage source V. Resistors A and B will create two oppositions in the current
They exit in the same path.
of the current flow. Assume you are traveling on a road at 40 km per hour with a motorcycle. Also, there are two bends A and B on the same road. At bend A, you have to slow down so the speed is reduced to 20 km per hour. After crossing the bend, you may reach a speed of 40 km per hour. Again, at bend B, your speed becomes 20 km per hour. Since both the bends lie on the same path, there is a total loss of speed of 40 km per hour. Here, the bend is analogous to resistance and the motorcycle as current. So, when the resistors are connected in series, the current flow is opposed by the times and values of the resistors. Simply, when resistors are connected in series, all add to the values together and substitute them in the formula. Let A and B's resistor value be 20 and 40 ohms respectively. Connect a voltage source or battery with 10 volts. Now let's calculate the current flow using Ohm's law. Since the resistors are in series, just add both the values and we will get a total resistance of 60 ohms. Now substitute the values of voltage and current in the formula I is equal to V by R. It becomes I equal to 10 by 60. You will get the current flow, which I read as 0.16 amps. Now add one more resistor C to the same circuit consisting of 30 ohms, so the total resistance becomes 90 ohms. Substitute the values in the formula, you will get I equal to 10 by 90.
Current flow rate
0.11 amps, no matter how many resistors are connected in series. Convert them into a single value by adding all the values. Example 2. Let's calculate the current in a parallel circuit using Ohm's law. Assume the two bends occur separately on two paths, C and D, with one bend at each as in a parallel circuit. Imagine you are traveling with a motorcycle at the same speed of 40 km per hour. At a junction of two paths or roads, you can travel on either of the paths. If you turn at path C, you will meet a bend at which your speed may be reduced to 20 km per hour. Or if you turn at path D, you will meet a bend. Here also, you have to reduce your speed to 20 km per hour. So the total reduction in speed is 20 km per hour. In the previous example, we have analyzed that the reduction in speed is 40 km per hour when the bends occur in back-to-back as series. But in parallel bends, the reduction in speed is only 20 km per hour. So coming to the point, in a series circuit, the resistance will be high, whereas in a parallel circuit, the resistance will be less. Let's connect the two resistors R1 and R2 as 20 ohms and 40 ohms respectively in parallel with a voltage source or battery of 10 volts. First, calculate the total resistance using the formula R equal to 1 by 1 by 20 plus 1 by 40. R equal to 13.33 ohm is the result of this. Substitute the values of voltage and resistance in the formula I equal to V by R, I equal to 10 by 13.33. As a result of this, we get current as 0.75 ampere. If you keep connecting the resistors in parallel, the total resistance will keep on decreasing and the current will keep increasing accordingly. For examples 1 and 2, resistance increases and current decreases, and in parallel circuit, resistance decreases, so the current increases. Hence, Ohm's law is satisfied. Example 3. Let's discuss the relationship between voltage and current with the same series and parallel circuits. Replace the voltage source or battery from 10 volts to 20 volts. Now substitute the values of voltage and current in the formula I equal to V by R, I equal to 20 by 60. As a result, current I is 0.33 ampere. Previously, when the current was connected to 10 volts, we analyzed the current as 0.16 ampere. When we replace it with 20 volts, current becomes 0.33 ampere. As voltage increases, current also increases. Hence, Ohm's law is verified. Similarly, in the parallel circuit, replace 10 volts with 20 volts and substitute the voltage and resistance values in the formula. I equal to V by R, I equal to 20.13.33. So we get current at 1.5 amperes. Previously, when the parallel circuit was connected with 10 volts, we analyzed the current as 0.75 ampere. For the same circuit, when we replaced with 20 volts, the current became 1.5 ampere. Therefore, the voltage increased, the current also increased according to the Ohm's law. Thanks for watching. Have a good day.